This is a very interesting example. It says, suppose the center of a circle is at point P, which has the coordinates of -3 and 0. The center of another circle is at point Q, and that has a center with coordinates at 3 and 3. And the center of a third circle is at R, which has coordinates of 1 and -2. If the three circles intersect, that's where they're all going to meet. At point S, which is at -1 and 0, determine the circumference of each circle. Now, I'm not going to graph these circles because it's just cumbersome for me to graph circles, but you do have to have a bit of an understanding of what's going on when we have these three circles. So I have a graph of or a picture of a circle here. Now imagine you have another circle. For these two circles to intersect, they would probably have to look something like this. I mean, they could intersect anywhere, but if they were to intersect something like this, the most they're going to intersect at is at 2 points. And you could see here's one right here, and here's a point right here. Now, suppose we have a third circle. If we have a third circle, that could intersect just about at any possible combination that you can think of here. But for the three circles to intersect all at the same point, it might have to look something like this. And as you can see, here it is right here. So the idea is that for three circles all to meet at the same point, that could only happen at one spot. So now if I was to go ahead and maybe draw the radii for each one of these, so maybe here's the radius for this one. It goes from here to the point where they all intersect. Here it is right here. And then if I do it for this one to the point of where they all intersect, it looks like this. And then of course for the third circle, maybe something like this. So what this question is asking for, it says, if the three circles intersect, that's where they all meet at this particular point, determine the circumference of each circle. And if you remember, the circumference is C, that's equal to 2 pi r. So in order to find the circumference of these three circles that are mentioned in the problem here, I have to find the size of their radius. So as long as I know where their center is and their endpoint is, I could determine the size of the radius. So this particular circle here has a center at P at this location and has an endpoint at S here at this location. This circle, the second circle, has a center here, but has the same endpoint. And of course, for the third one here, that has a center here, it also shares the same endpoint. So in order to find the size of each radius, that's going to be C is equal to the square root of a squared plus b squared. And as long as I know the centers and their endpoints, I could just figure it out algebraically or mathematically. So we'll do that. So I have point P at -3 and 0, and it's got an endpoint at S at -1 and 0. A is equal to the absolute value of the difference of the x coordinates. So I got -3 minus -1. That comes out to be the absolute value of -2, and the absolute value of -2 is 2. B is the difference in the absolute value of the y-coordinates. Well, they're both 0. So B is 0. So then I go ahead and I do C. That's equal to the square root of a squared plus b squared. Well, a squared, that's 2 squared. And this is just going to be 0. This becomes the square root of 4. And of course, the square root of 4 is 2. So the length of the radius for this particular circle here with a center at -3 and 0 and an endpoint at S is at -1 and 0 is 2. So its circumference is going to be 2 pi r, and its radius is 2. 2 times 2 times pi, that's 4 pi. And of course, then you can use your calculator. Type in 4 times pi, and that's approximately 12.57 units. Then we do the same for this circle here. Of course, it has a center at 3 and 3. But it shares the same endpoint, which is S at -1 and 0. A is going to be the difference of the x-coordinates. That's going to be 3 minus -1. That's equal to the absolute value of 4, and the absolute value of 4 is 4. B is the difference of the absolute value of the y-coordinates. That's 3 minus 0. That's the absolute value of 3, and the absolute value of 3 is 3. So then C is equal to a squared plus b squared. A is 4 squared. B is then 3, so this becomes 3 squared. This is the square root of 16 plus 9. That's equal to the square root of 25. And the square root of 25 is 5. So the circumference, that's 2 pi r, and r is 5, so 2 times 5 is 10, that's 10 pi. And again, you can use your calculator, plug that in your calculator, and that comes out to be approximately 31.42 units. And of course, we do it for the last one here. We have a center at R, which is at 1 and -2. And it shares the same endpoint, S at -1 and 0. A again is the absolute value of the difference of the x-coordinates. That's 1 minus -1. Don't forget that's this one here. Is 2. B is the absolute value of the difference of the y-coordinates. That's -2 minus 0. That's the absolute value of -2, and of course the absolute value of -2 again is 2. So then the length of the radius, that's the square root of a squared, which is 2, that's 2 squared, plus b squared, which is 2, that's 2 squared. That's 4 plus 4, which is the square root of 8. We're not going to approximate this. We'll wait until we go ahead and plug it in for our circumference. So our circumference is going to be 2 pi r, and r is the square root of 8. So you could plug that in all in your calculator. You could take 2 times the square root of 8 times pi, and that all comes out to be approximately 17.77 units. So the circumference of this particular circle with its center here and endpoint here is 12.57 units. The size of this circle here, which has a center at 3, 3, and has the endpoint over here, the same one, -1 and 0, that has a circumference of 31.42 units. And of course the third circle here, which has a center here and the same endpoint, that has a circumference of 17.77 units.